Why is the night sky dark?
Because it's nighttime. Boom.
Let's take the sun for a moment, okay?
All right.
And it has a certain size on the sky. And there's a certain amount of light coming from the sun, and it's very bright, okay? But there's something called surface brightness. It's a very important term in astrophysics. So it's not what the total brightness of the thing is. It's how much light is coming from a particular area on the sky. Okay. So that would be its surface brightness.
All right.
Surface brightness. Okay. So now watch what happens. If I put the sun 3 times farther away,
right,
its area on the sky drops to 1/9 of what it was before. It goes as the square of the distance. Okay.
All right.
Okay. So it's 1/9 as large. Okay. Because 3 times farther away, it's like 1/3 its height and it's 1/3 in the width. And in the area, you're down by a factor of 9. Okay. So that's the mathematics of that, right? It's 1/9 as large. Are you with me?
I'm with you.
Okay.
I mean, or as I would say, it's smaller.
Okay, good. Okay. So, but precisely 1/9. Not only that, if it's 3 times farther away, something called the inverse square law of light drops the total brightness by the distance squared. So if it's 3 times farther away, 3 squared is 9, the brightness you're receiving from the sun is only 1/9 of what it was before.
Okay.
Well, wait a minute. If the sun is 1/9 as large and you're getting 1/9 the light, if you divide those two, then 1/9 cancel. It has the same surface brightness as it did when it was closer.
Ooh. Well, that was a neat little trick.
That's what I'm saying. It's a mathematical reality of the geometry of what's going on.
Cool.
Okay?
Love
so what that means is you could put the sun at any distance from you, and a sight line to its surface will be just as bright as a sight line to a spot on its surface if it's close up.
Right. Okay, that makes sense. I love it.
Okay, so Olbers, you forgot about him, right?
Yeah,
Heinrich
the
Wilhelm.
dummy who didn't know why nighttime exists.
The dummy. Dummy.
Olber's dumb. That's what it means in German. Dumb. Dumb in the dark.
So he said to himself, if the universe is infinite,
okay,
then every sight line should land on a star. And if every sight line lands on a star, then the entire night sky should be as bright as the surface of the sun.
Whoa.
It should be ablaze in light.
Yes, because even though you're moving them farther away, they cancel out in the inverse ratio.
Inverse ratio, correct. Inverse square ratio. Right.
So inverse square ratio. Okay. And so, boom, it's still just as bright. So now it doesn't
Bada
make a
bing.
difference where you look.
So the surface brightness. And you're talking about where you land on the sky, right? The sky. So if you have an infinite universe and stars are everywhere, your sight line would eventually hit the surface of a star.
Right.
And the surface of a star would then be just as bright. I mean, within the variations of stars, be just as bright as the surface of the sun.
And so
it was a paradox. And the night sky,
there should be no darkness.
Correct. And so the night sky is not completely dark.